Hey, James here. Welcome to another video. Today I was really occupied hours for hours investigating and examining, but only for my self-interest, to find patterns, geometrical patterns or patterns in numbers. What I mean by that is that normally in the school you always have a given figure or geometrical form, like a circle, a triangle, a square, or rectangle, and all the others, and then you add value to those body shapes, forms, geometric, like numbers, for instance, value numbers, or letters, ABC, XYZ, and obviously numbers. So what you see here is I'm trying to find geometrical forms, figures, and patterns in numbers. And the reason why I came to that, because I examine and study a lot of Plato, Pythagoreans, Aristotle, and all that, because you learn a lot from their quotes, but people actually mostly are not interested in quotes. They're more interested in their work, what they do. But I figured out, if you understood the quote, their own quote that came out of their mouth, there's something always unfolded beauty into it. So the reason why is I have it here is because of the Pythagoreans. And as you know, the Pythagoreans were masters in numbers and geometry. So one of the famous quote from the Pythagorean was, "The importance of pure numbers is central to the Pythagorean for the view of the world. A point was associated with 1, a line with 2, a surface with 3, and a solid with 4, and there is some 10. 10 was a sacred number." So I was interested more in those numbers they saying, like 1, 2, 3, 4, the sum of it is 10, and 10 is a sacred number. So 10 is a sacred number, and 1, 2, 3, 4, if you add it on, it becomes 10, obviously. So I just kept doing this sequence of numbers, like as you see here is 1, 2, 3, 4, then 6, 7, 8, 9, then 11, 12, 13, 14, all the way down till 49. And what you figured out is, and that's the interesting part, is that the Pythagoreans didn't mention the number 5. So I left out all the 5s in these sequences. So you won't see any 5 in this content. You won't see any 10 in this content, which means a 0, right? Like 1, 0, 2, 0, 3, 0, and etc. Like 10, 20, 30, 40, 50. You won't see it in this content right here. So you won't see also 45, 35, 25, 55. You won't see it in this content. So that's why you see 1, 2, 3, 4. The 5 is off. 6, 7, 8, 9. The 10 is off. 11, 12, 13, 14. 15 is off. That's why 16, 17, 18, 19, and 20 is off. So I saw 21 and so on till 49. So, and as you know, I also drew a square on it. I don't know why, but it's just like some art thing. It's just for myself. So, as it says, that for me it's very interesting when we try to find patterns in numbers, and you rarely see numbers like this in front of you, right? They're always, you see only like 2 numbers in front of you, and they are divided, or there's another symbol between. So you rarely see numbers like this in front of you, flat laid out. I only think I saw it when you play Totoloto or Powerballs, then you see the numbers like this in front of you, and I found it very interesting. So as we know, as the Pythagorean says, and it's true, 1 plus 2 plus 3 plus 4 is 10. So let me write 10 down here. And it's just for me, I draw down a horizontal line on it because we go horizontal and we get the sum of 10. We go further, it's going to be then obviously 30. And then this line is 50. And then this line is 70. This line is 90. If you add those numbers together, it's 110, 130, 150, 170, and 100. The last row, 190. Oops, that looks a little bit messed up. The 90, right? Let me just so you can see better. So the sum on the right side is the sum from the numbers on the left side. So as you see, 1 plus 3, 1 plus 2 plus 3 plus 4 is 10, 6 plus 7 plus 8 plus 9 is 30, 11 plus 12 plus 13 plus 14 is 50, and so on, right? Just that you see it, that it makes sense. So what I instantly figured out is when I look at the numbers in front of me, at the sum numbers, that I figured out that you see the sums are uneven or prime numbers, right? You see it here. It's 1, 3, 5, 7, 9. And then it goes again. It sounds like 1, 3, 5, 7, 9. And it will go on 1, 3, 5, 7, 9. 1, 3, 5, 7, 9. I know that because here you just see till the numbers till 49 because I don't have so much space here. But I did it on my paper on the computer, and I go all the way down to 100 and instead of 49, 179. So I know that it goes further always like this. So it goes always 1, 3, 5, 7, 9, 1, 3, 5, 7, 9, 1, 3, 5, 7, 9, 1, always like this. Another interesting thing is what I figured out is that when you go in a horizontal way, when you add the numbers together, you get those uneven sums, like, you know, right? 10, 30, 50, 70, 90, etc. I figured out when you use, I don't know which color should I use. Let me use, it's like, let's say blue. I figured out when you, hold on a second, it's gonna be, that when you add those numbers, and here again geometry, when you add these numbers together, the sum of these numbers gives this even sum. So 1 plus 7 plus 13 plus 19 will give 40. Now when you go in diagonal way more down, which is the next, on the next line is 6, 12, 18, 19, 6, 12, 18, 24 will give 60. 24 will give 60. Just let me make a connection. And if we go further down, 11, 17, 11, and also diagonal. 11 plus 17 plus 23 plus 29 will give 80. I know that because I have it all, everything what I explained here, I have everything full on my paper. So 11 plus 17 plus 23 plus 29 will give 80. I'll put it between 80. And the same thing here, it will then give 16 diagonal, obviously. 16 plus 22 plus 28 plus 34 will give 100. So and it's just for myself. I figured out that this is on this graphical, it's going to be on the right side, the sum, which I marked the black. So the other thing is, if I add a diagonal in a diagonal way, those numbers, it will give, if I do this one, right, in diagonal numbers, all the way down, it will give all, so all the on the left side, all, when I add the numbers in in diagonal form together, it will give all the even sums, which you see here, 40, 60, 80, 100, and that's quite interesting. So when I add the numbers in a horizontal way, right, oops, damn it, it should be red, sorry, my bad. If I add it in a horizontal way, right, on the left side, you get all the uneven numbers and prime numbers, like 10, 30, 50, 70, 90, 110. To get the even numbers, that the sum is an even number, I have to add the numbers in a diagonal frequency together, like 1, 7, 13, 19 is 40. 6 plus 12 plus 18 plus 24 is 60. So now we fill in the even sums in there. Now it becomes interesting. So, and if I put here the number 6 over here, it's also a very interesting number, the 6. Then you will see that 6 plus 2 plus 8 plus 4 will give 20. Now, so it's an interesting thing. So the horizontal will give all the uneven sums, like 10, 30, 50, 70, 90, and so on. And when I add the number in a diagonal form, like this, in a diagonal form, I get all the even numbers, right? So let me write here even, and besides the 10, that's why 10 is a sacred number. It's a very interesting thing, the number 10. And here the uneven numbers. All right. So another thing what I discovered on when I have it here in front of me is when I look. So by the way, if I keep doing this diagonal adding numbers here down, like 21 plus 27 plus 33 plus 39 will give 120, and it's always like this. I know that because I have it. I just don't know, because otherwise you get confused. Another thing what I have discovered is that when I look in a vertical way, right, in a vertical row, vertical, line each number line down, I figured out something also very interesting. That is that all the ones, it's 1 1, and then interestingly it's 2 2, and then it's 3 3, and then it's 4 4. What I'm saying you now, I know it because I have on my paper, as I said previously, it's going to be like 5 5, and then 6 6, then 7 7, then 8 8, then 9 9, and then it starts back up again, 1 1, 2 2, etc. Then the next line is always going to be 6 1 6 1 6 1 6 1 6 1 6 1. So, and 6 1 always here, it's always going the same like above, and then it comes interestingly back to we had in the first row, vertical row, is 1 1 2 2 3 3 4 4, and then 2 7 2 7 2 7 2 7 2 7 2 7, and then again 1 1 1 1 2 2 3 3 4 4, and then 3 8 3 8 3 8 3 8 3 8, then 1 1 2 2 3 3 4 4, and then 4 9 4 9 4 9 4 9 4 9. So what you see here, that it goes always up 1 on the in a vertical line. It goes always up 1. I found that also very interesting. So let me just, okay, I got that, I got this, I got that. Okay, and so what I also want to say is that the zeros in the 1 are actually really not necessary. The 0 and the 1s, I think it's only important for machine binary. Like we know that computers just know 0 and 1, 0 1, and on any other numbers the computer actually doesn't give a damn. So it's the binary codes 0 1 or 1 0. And I found something very interesting why you get out of these numbers always the 0 1 0 1 0 1 0 1. But I will do that in a later video because otherwise it gets too confused. So that's what I found. Another pattern, so it's 1 1 2 2 3 3 4 4 and so forth, and then 6 1 6 1 6 1 6 1, etc. Another interesting thing is that, let me just look at it. When you go this way around diagonal, it will give the same sum. It will come here then 10, 20, 30, 40, 50 when it goes this way. Hold on, let me just, I got it here on the paper. I don't want to explain too much in the beginning because you will get very quick lost. But anyway, if you add the numbers instead of this direction, you add those numbers in this, like we did it here, diagonal, it becomes 10, it becomes 20, diagonal becomes 40, all the even numbers. The same thing will happen on the other side. Hold on, let me see. No, I don't have it. I have it on the other paper. But anyway, it will be the same thing on the left side with 10, 20, 30, 40, 50, like you see it here on this side. So I found it also very interesting. So I will make as well those lines because it will go also the sums, right? And it will also give the even and the uneven numbers. So, and then we have here the vertical lines that goes also down, right? We found their patterns and all that. Now see, the graphic becomes very interesting on this side, right? And I find it also very interesting. But there are many things what I have discovered, but I will show you in the next video. So important for this part 1 is now that I figured out that there are patterns, geometrical patterns in numbers, but only if you have the numbers in front of you laid out. Which means you only see that when you play Powerball or Toto Loto and stuff like that. Otherwise, you don't really see it like this in front of you. So what I did is I wrote down the numbers from 1 till 49, and I used a quote from the Pythagoreans that said that 1, 2, 3, and 4 is 10, and 10 is a sacred number. So I kept that sequence like 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way down to 49. You won't see in this content, in this specific content, you won't see 5s, you won't see 10s, 20, 30, 40, you won't see 45, 35, 25. I left it all out. Now, on the right side, you see all the sums that comes together if you add these numbers in a horizontal line together, like 1, 2, 3, 4 is 10, 6, 7, 8, 9 is 30, 11, 12, 13, 14 is 50, etc. And then we figured out that the sums are all uneven numbers and are prime numbers. Then we also figured out that if I add the numbers in a diagonal form, right, this diagonal form, it will bring the sum on an even number, right? Like here, 6 plus 2 plus 8 plus 14 will give, 6 plus 9, 6 plus 2 plus 8 plus 4 is 20. 1 plus 7 plus 13 plus 14 gives 40. 6 plus 12 plus 18 plus 24. Oops, I don't want to get 6 plus 12 plus 8 plus 24 gives 60, and so on. So the diagonal numbers will give, if you add diagonal numbers, will give the even numbers. If you do it in a horizontal line, will give the uneven and the prime numbers. And I showed it here in a graphical way. Here on the right side, so this is the geometry, the pattern, what I found in numbers, just in pure numbers, right? I see those patterns. And also, I forgot to add on, but I don't have another color, those patterns, like I said, like 1, 1, 2, 2, 3, 3, 4, 4, etc. will be signed here, but there's too much colors. It's just like that you see those patterns. I found interesting in the model to the right side. Another interesting thing is that, no, I think we leave it by this right now. That's the first part of the video, finding patterns and geometry in numbers. So it's really numbers, and I try, if I have, it doesn't matter how many numbers I have in front of me like this, I find patterns, geometrical patterns in those numbers, which I have drawn on the right side, right? These are all geometrical patterns and forms, excuse me. And I made it on my paper on the computer. I made it instead of here, because I don't have so much space, only till 49. I have it already all the way down to 179, so I know how everything goes. So these are, we found out so far, is the horizontal patterns. Forgot to put it in. So we have a horizontal pattern, we have horizontal pattern, we have diagonal patterns, and we have vertical patterns, and we have, I call it neighbors pattern, right? Which is all represented in here. So stay tuned for my part 2 video. I know it's a little bit complicated in the beginning, but I'm telling you that if you only have laid out numbers in front of you, it doesn't matter, you start from 1 till 5,000, you see a lot of patterns in numbers. Not like we used to do it and we learned it in school, that we have already patterns and geometrical figures in front of us us, and we add to those shapes and figures and forms, we add values onto it, which is represented by numbers and by the alphabet letters. But on this here is the other way around. I find out patterns in geometrical figures and forms in numbers, in pure numbers. So thank you for watching. Stay tuned for my part 2 video. Yes, and goodbye.